Hello viewers, in today's class we are going to discuss one important concept from three-dimensional geometry, right? So here we'll discuss the concept of a plane containing a given point and a given line, right? And we'll discuss this concept with the help of this example, right? So let us first read out the question. Here we have to find the equation of a plane containing this point A, whose coordinates are 3 comma 2 comma 0, and the line x minus 4 over 1 is equal to y minus 7 over 5 is equal to z minus 4 over 4, right? So here we need to find out the equation of a plane which contains this point and this line, right? So the problem goes like this, that if we have a plane, say this plane is denoted by the letter pi, and this plane contains a point, say A, which is 3 comma 2 comma 0, and a line, say L, right? So this plane pi, and we have to find out the equation of this plane pi, right? So let us denote this line as L, right? And here we have the point A. Now see, suppose we have a plane pi, then the normal to this plane pi is like this, right? Then this is the normal vectors. Let us denote it by n cap, right? So this is the normal vector to this plane pi, right? So now the situation is like this. This normal vector is perpendicular to this line L, right? So here this is the angle, that is 90 degrees, right? So now we know that the equation of a plane which passes through some given point, say x1, y1, z1, right? See, we know that the equation of this type, say ax plus by plus cz plus d is equal to 0, this equation always represents a plane, right? And here the coefficients of x, y, z are a, b, c. So a, b, c are the direction ratios of the normal vector, right? So here we have the normal vector. We can take it as n cap. This is the unit normal vector, and if we take it as vector n vector, then this is the normal vector, right? So a, b, c are the direction ratios of this normal vector. So equation of a plane passing through one point, say x1, y1, z1, here we can take this point as x1, y1 and z1, right? So equation of such a plane is always given by a times x minus x1 plus b times y minus y1 plus c times z minus z1 is equal to 0, right? So the modified form of this equation is this equation, right? Because if this equation passes through x1, y1, z1, we can easily get this equation, right? So here a, b, c are the direction ratios of the normal vector. Now let us take x1, y1, z1 as 3 comma 2 comma 0, right? So we'll have a times x minus 3, then we have b times y minus 2, then we have c times z minus 0, right? And let us denote this equation by equation number 1, right? So here our prime aim is to find out the values of a, b and c, right? And a, b, c are the direction ratios of the normal vector, right? So once we are able to find out the values of a, b, c, we can substitute it over here, and we can easily get the equation of the plane, right? So let us try to find out the direction ratios of the normal vector. So now let us now take the help of this equation of line. right? So here the given equation of this line L is x minus 4 over 1, y minus 7 over 5, and z minus 4 over 4, right? Now if we look at this equation, then we can conclude two things from this equation, right? So the number one is this line L, it passes through the point 4 comma 7 comma 4, right? 4 comma 7 comma 4, right? So we can easily deduce this result by comparing this equation with the equation of a line, say x minus x1 over a1, y minus y1 over b1, z minus z1 over c1, right? So this line L, it passes through 4 comma 7 comma 4, right? And the second thing is that this line has the direction ratios as 1 5 4, right? So the direction ratios of this line are 1 5 and 4, right? So now we'll use both these things to get the equation of this plane pi, right? Now see, the line, it lies on the plane, or in other words, this plane pi contains this line L, and this point lies on this line L. So this point 4 comma 7 comma 4 must lie on the plane. So this point must satisfy this equation 1, right? So now if we replace x, y and z by 4, 7, 4, then we'll get from equation 1 a, and here we have 4 minus 3, then we have b, and we have 7 minus 2, then we have c, and 4 minus 0, right? And we can simplify it, so we'll get a, here 4 minus 3 is 1, then 7 minus 2 is 5, so we have 5b, and here we have 4c, right? So this is equation number 2, right? So what we have done here, since this line L lies on this plane pi, and this line contains this point, so this point is contained by the plane pi, hence this point must satisfy the equation 1, right? So replacing x, y, z by 4 comma 7 comma 4, we'll get this equation, right? Okay, now let us take the direction ratios of the line. So the direction ratios are 1 comma 5 comma 4, and the direction ratios of the normal vector are a, b, c, right? So here we have 1 5 and 4, right? So here the normal vector is perpendicular to this line L, right? And we know that when two vectors are perpendicular, then we have this condition, that is a1 a2 plus b1 b2 plus c1 c2 is equal to 0, right? Or in other words, the dot product must be equal to 0, right? So here we have a1 b1 c1 are the direction ratios of the normal vector, and a2 b2 c2 are the direction ratios of the line, right? So now we can frame the equation, that is a times 1, then we have b times 5, and then we have c times 4, right? So now we have the equation a plus 5b plus 4c is equal to 0, right? So now here we get an interesting situation, right? See, we have got the same equation, right? So here we can denote this equation by equation number 3, right? So initially we have got this equation, and then we have got this equation. So this equation is the result of direction ratios, and this equation is the result of this point, right? So now see, here we have got two identical equations, right? So let us assume that if we had these two equations different, then we could have solved these two equations, right? But in this case, we have got the same equations, right? So let us do how we can proceed further. So here we'll apply the method of hit and trial, right? So here what we will do, we'll make a guess here. See, here we have this equation a plus 5b plus 4c is equal to 0, right? Now if we make a wise guess here, see, if we take a is equal to 1 and c is equal to 1, then what we will get here, will get 1 and here will get 4, right? So 4 plus 1 is 5, and if we now take b is equal to minus 1, then this equation is satisfied, right? So here one set of values may be taken as 1, minus 1 and 1, right? So a, b and c can be taken as 1, minus 1 and 1, right? So now here the direction ratios of this normal vector can be taken as 1, minus 1 and 1, right? And if we now substitute these values in equation 1, see what we will get. We'll get 1 x minus 3, and then we have minus 1, then we have y minus 2, then we have 1, and here we have z minus 0 is equal to 0. So this is x minus 3. Here we have minus y plus 2. Then here we have z, and this is x minus y plus z. And here we have minus 3. Here we have 2. So this is minus 1, right? So we have got this equation, right? So now here we have seen that these two equations are satisfied by a is equal to 1, b is equal to minus 1, and c is equal to 1, right? And the required equation of the plane is given by x minus y plus z minus 1 is equal to 0, which can also be written as x minus y plus z is equal to 1, right? And this equation or this equation is of this form, right? We can also write the vector form of this equation, that is vector r dot vector n is equal to d. So we can also write this Cartesian equation in terms of vectors, that is vector r dot we can write I cap minus j cap plus k cap is equal to 1, right? So this is the vector equation of this plane pi, right?